Hi, welcome back to Element 14 Presents. My name is Mark. Today I'll be building a Parkstop Minion, and a Parkstop Minion is a little gimmick that you can put on your desk. It has some nice features, like a humidifier, because its main purpose is to create smoke, so people will think it's on fire. And I can mimic an angry mood with that, or a happy mood. Because I will also have an eye, a display that will mimic eye movement, so it can stare at you while you're sitting at your desk. It has a humidity sensor, so you can measure the humidity in the room, and the temperature of course. And it will have a speaker and a microphone, so we can even use it to create some funny sounds. And in the future I might even update it to function as a radio, because I'm using an ESP32 and it has onboard Wi-Fi, so that's a possibility. Let me walk you through the schematic first. First we have our ESP32, it's the center of all. We have a soundboard connected to I2S and a microphone also connected to an I2S bus. We have a potentiometer that I can use to set the volume, a resistor network that has one light depending resistor, so I can use that to detect whenever somebody enters the office in the morning and turns on the light. We have a temperature and humidity sensor. We have our display, a little power section to create a 5-volt output, and we have a push button, so we can switch display between maybe the eye that I want to display and the humidity and temperature. Then we have a little circuit that powers on my actual humidifier. It's a little resistors with 2 FETs that will basically switch on and off whatever is connected to CN3, which will be my humidifier. So that was the schematic. Now I did design the PCB for this, and I'll show you in a bit when I zoom in. I designed it to make it easier to assemble, or basically to make it fit in the Minion. And we're going to assemble that in a bit, but first let me show you the rest of the components. So this is the PCB. We'll be using a speaker, an ESP32, a display, a lens for the display, a humidity and temperature sensor, an LDR, a MEMS microphone, an audio board, a little push button, some connectors, and a trim potentiometer. And of course we have our humidifier. And the humidifier is an assembly that I bought in China. It has its own PCB and the actual piezo that's used to create fog. Now what you see in white you need to put in water, and for that I use a little test tube that fits perfectly, so I can fill that with water. And that will be inserted in the Minion later, like so. There's a hole in the top that will fit that completely, but we'll see that in a while. And then of course we have some small components. Let's get started. Well, as always, the first thing I'm going to do is apply a little tin on one side of the soldering pads, because I don't have stencil and solder paste, and there's only a few components. This will work just fine. Like so. So let's start putting the components. Let's start with, let's see, and then I just do the other side. So now that all soldering is done, let me check all the components to see if I didn't miss anything. Nice. Okay, so in general, when you look closer at these SMD soldering, it looks kind of messy, but for prototype it's okay, it will do. You can clean it up with some little flux cleaner or alcohol, and you can even solder it again using flux, and then just apply flux and reheat it, and it will flow out perfectly and smoothly. But for now it's unnecessary. So let's continue with the regular components, the through-hole components. Okay, so I sliced the poppet in half so it's easier to see. You see 3 buttons or 3 holes, and actually one is for the LDR, one is for the switch, and one is for the microphone. And the PCB is mounted in the back like so. So there's a gap between the PCB and the front. And I need this microphone to be in the right position. So if I put it like this, then it's still a lot of ground to cover to finish the gap. So, okay, so let me apply these sockets. If we apply it in here, I must say that's better, because the gap is smaller. Okay, so first we have to remove the humidity sensor from the PCB it came with, like so. Discard the PCB, and the sensor we're going to mount here. Okay, so you can mount it straight, doesn't really matter, it's inside the housing anyway, or you mount it at an angle. And I'm going to choose the latter, like so. Let me first do one side again. When that is done, rearrange everything and do the other parts. Okay, so we have a microcontroller that I put on sockets, that goes there. And I'm going to solder those. That will be the regulator. One important one is the display. Only one thing left, and that's the board I have for my humidifier. Okay, so I was mounting everything together and doing some pre-testing, and I actually discovered a huge design flaw. The component I used for the display came from a standard library, and it was all configured wrong. It's basically mirrored left to right. So for this, or in order for this to work, I either need to flip it over like this or like this. So guess what? I desolder it, and of course I'm going to flip it like this, and then the whole PCB will be flipped. Which means it's going to be a bit tight for the humidifier, but for now it'll work. What's important for you, if you're going to build it and you take my design files, I will adjust the PCB so you can just build it like this, mount it there, and then everything will be fine. But for now I will put the LCD on the bottom and the switch on the bottom and the display on the bottom and hope for the best. Okay, so I adjusted it, the LED, or sorry, the LDR is at the bottom, the switch is at the bottom, and the display is at the bottom. And for now I did it like this. Again, if you're rebuilding this, I will make sure the PCB layout has been corrected so you can just mount everything on top. But for now, this is going to be the situation. Yeah. And yes, I do need to extend that switch that is there. I will do something for that. Okay, with the electronics all finished, it's time to assemble everything and make the puppet complete. Okay, the first thing you need to mount is the lens in the housing. Just simply push it in there, wiggle it until it fits, like so. That's in place. Okay, so next is the PCB, the one you already assembled. Yours might look a bit different because my display was mirrored, so maybe yours is going like this, mine is going with the microcontroller up. That's important for when you connect the two connectors later. One is for the power and one is for the speaker, and don't mix them up. And of course we have our humidifier. So let's start with those. Before I put it in place, let me solder a wire to the connector for the humidifier. That's two. Then of course we have our power, which is this one. That's also a wire. I could use a connector, but I right now prefer soldering it, so you could have left out the connector and soldered directly on the PCB, but that's okay. For now, I'll just do it like this. Make sure you don't mix up the polarity. So that's the power. And the speaker, I already have a connector, I can just use that and plug it in. Now, to mark which is what, let me put a little knot in the wires to remember that these are for the humidifier. Before we assemble the PCB in the housing, we do need to install a few connectors first. One is for the power, and that goes in this one, all the way in the back, like so, because that's going to be our power source later. Yep. And of course we have the one for the humidifier, which is a mini jack that I put here. And first we're going to connect the power and the humidifier. Yep, this one will go. This one will go here. And the other one will go there. So this is our humidifier with a connector to take it out if I need to refill it. That's right. And then the speaker will connect. That goes right there. And now it's time to put all of this in here. Like so. And that's all there is to it. Now I'm going to use some hot glue to hold, or just glue to hold those in place so the PCB doesn't fall out. And then the speaker will just rest at the bottom. I'll do all that in the end. When this is glued together, then the speaker will be just resting in there. Like so. Okay, let me get the glue. Before I make this assembly final and glue everything together, I do need to program it first, and for that I'll use USB programming with a web browser. I will include the sketch files for you to see and to work with. If you want to change it, then you can recompile it and upload it. But for easy programming, you can simply use the web interface and we'll do USB programming. Okay, so the programming is going to be easy because we're going to use web-based programming. You can just go to a website that you see here, this website. We will include that link, and when you go there, you come to this site, you hook up your ESP32, you press install, select the right COM port, and you can just click connect, and it will start programming. And then we wait until it's all done, and you're good to go. And then you're all done. With all the programming done, it's time to glue everything together. Okay, so the test tube is in place, everything dried, and then I will just apply a few dots of glue around the surface and then glue it all together. Same goes for the speaker, it goes in here, I will glue it, and then you're good to go. Okay, so I might have jinxed it a bit by trying to add artificial smoke. At some point I really short circuit piezo element and I created some real smoke from the PCB. I fixed all that and I won't make that mistake again. Actually, what this device will do, if it's switched on, the eye will gaze at you, and when it produces sound it will also create smoke. And the trigger for making sound at this point is too much loud noise. So if your colleagues are too loud in your office, then this device will basically say, psst. So what happens if I talk too loud? Psst. Hey. Psst. You mean you will create smoke? Psst. Hey. Psst. Okay, so this Minion can also give you the actual temperature and humidity and the humidity index. And of course, you know, what other people have with Doom, I have with analyzers. Will it run an analyzer? And yes, it does. As you can see, there's a nice audio analyzer. Well, it runs a lot of things, and it does run a spectrum analyzer. It doesn't run Doom though. I didn't try, I mean. Maybe it runs Doom, maybe it doesn't. But it runs a spectrum analyzer. Oh yeah. Hey. This is all I have for you today. I hope you enjoyed it. Remember, at the Element 14 community there's a project page where you can find all the information you need to build your own desktop body, or as I call it, the Parkstad body. And you can leave comments, make suggestions, and I do my best to answer each and every one of you. While I think of a new video, I'm going to play around with this in the office and have some fun. Until then, I see you next time.